protein bioinsecticides advance toward market use. As scrutiny around conventional pesticides intensifies, biologically derived crop protection tools are moving from concept toward early validation. A recent research milestone from Biotalis, working alongside Syngenta, signals incremental progress in protein-based insect control, an area gaining traction across the industry. The work centers on Biotalis' agrobody platform, which applies engineered proteins designed to interact with specific biological pathways in pests. Initial laboratory data has shown in vitro activity against select insect targets, offering early indication that this approach could introduce a new mode of action into the market. While still at a research stage, the implications are notable. Crop protection pipelines have historically leaned on synthetic chemistry, but resistance trends and environmental constraints are pushing companies to diversify. Protein-based actives, if proven effective in real-world conditions, could complement existing tools rather than replace them outright, particularly within integrated pest management (IPM) systems. The collaboration itself reflects a broader industry pattern. Smaller biotech firms are increasingly pairing platform innovation with the scale, regulatory experience, and distribution networks of multinational agribusinesses. This model is becoming a practical route to move early-stage science toward commercial viability. Balancing efficacy, regulation, and scale, the timing of these developments aligns with growing pressure on growers. Resistance to established chemistries continues to spread across key crops, while regulatory frameworks in several regions are tightening the approval and use of traditional pesticides. Protein-based bioinsecticides are being positioned as one response to these constraints. Their targeted design may help limit off-target effects, including impacts on beneficial organisms, while introducing new mechanisms that could slow resistance buildup. That said, performance consistency remains a central question. Moving from lab results to field application introduces several challenges. Biological actives must maintain stability under variable environmental conditions, scale efficiently in production, and meet regulatory standards that are still evolving for newer categories of crop inputs. Each of these factors will influence how quickly such products can reach growers. The next phase of the Biotalis-Syngenta collaboration, transitioning into in vivo testing, will be a key checkpoint. Demonstrating effectiveness in living systems is often where early promise is either validated or falls short. At the same time, the financial realities of agtech development remain in play. Advancing new crop protection solutions requires sustained capital, and early-stage companies face ongoing pressure to secure funding while progressing through lengthy development timelines. Taken together, protein-based insect control represents a potential shift in how the industry approaches pest management. But the path forward will depend less on early lab success and more on whether these solutions can deliver reliable, scalable performance under real-world conditions.